Alright, what's up everybody? We are getting into Unit 8.4, Trigonometry. Okay, so today's video is going to be pretty short. We're going to break trig up into 3 sections. The first section is going to be how do we set up the ratios. Second section, how do we use those ratios to solve for side length. Third section, how do we use those ratios to solve for angle measures. Then we'll get into word problems with trig, and then we'll get into something else. Okay, so we're going to be in trig for the next couple of weeks. So trig comes from 2 Greek words being sandwiched together, right? So trigon meaning triangle, and metron meaning measures. And the thing to know about right triangles is there's only so many different combinations that we can have, and every time you have a right triangle, there's a special relationship between the angles and the sides. And those measurements and those relationships are constant, okay? And because they are constant, we are allowed to solve for missing pieces of information given very little information. So a trig ratio is the ratio of 2 sides of a right triangle. Now it could be a leg and a leg, or it could be a leg and a hypotenuse. Because remember, there's only 3 sides, 2 types of sides. There's 2 legs, 1 hypotenuse. So again, it's either a leg-leg ratio or some type of leg-hypotenuse ratio. Remember, a ratio is a fraction for us in this sense. So we use trig ratios to find missing angles and sides of right triangles. And the key is all in making the setup. Once you have the setup, solving it is pretty straightforward, but getting the setup correct, that's where the key is for today, and that's where we're going to be focusing on. So each ratio is created based off the focus angle. So what I mean by the focus angle is either the angle measure you are given or the angle measure you are trying to find. Okay? One important piece of information: the right angle will never, ever, 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 ever be the focus angle. Okay? If you change your focus angle, then the ratio is going to change. So deciding what your focus angle is determines how you set up and solve your problem. So take a look at this triangle. I have triangle ABC. I have side lengths X, Y, and Z. So as I said already, the right angle will never be the focus angle, meaning in this diagram, either angle A could be our focus angle or angle B could be our focus angle. Okay? Based off your focus angle and the information you are given, that is how you determine how to solve your problem using trig. Okay? So, we have this little silly acronym that helps us remember how to set up the ratios, and it's called SOHCAHTOA. 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 Okay? So the S stands for sine, the C stands for cosine, and the T stands for tangent. Okay? S for sine, C for cosine, T for tangent. Okay? The O is an opposite, the H is a hypotenuse, and the A is adjacent. Okay? So, one more time, actually, let me write that out for you guys just so we have it. So, O equals opposite, A equals adjacent, and H equals hypotenuse. Okay, and that's going to be important because so O and H and A are determining the sides are determining the sides of the triangle you're looking at. And I'll explain how that works here in a second. But the first letter in these acronyms is the trig function, whether it's sine, cosine, or tangent. The second two letters are the two sides you're going to use to make your ratio. So for a sine, you're using the opposite side and the hypotenuse based on where your focus angle is. For the cosine, you're using the adjacent and the hypotenuse, again, based on where your focus angle is. And for the tangent, you're using the opposite and the adjacent. So notice tangent does not use the hypotenuse in its ratio. Okay? So, as I said, sine is opposite over hypotenuse. So the middle letter is always your numerator in your ratio. The third letter is your denominator in your ratio. So sine is always opposite over adjacent. Okay? So let's say we make our focus angle A. So if my focus angle is A, think about the sides of the triangle and how they relate to the location of your focus angle. So if I'm focusing on angle A, Y is always going to be the hypotenuse, no matter if I'm focusing on A or B. However, if my focus is A, the side opposite that is Z. The side adjacent, the side touching angle A, is X. So if my focus angle is A and I want to write the ratio of the sine function, A, where this A is right now, that is holding the place of the actual angle measure. So it would be like the sine of 57 degrees or the sine of 62 degrees. So the sine of A would equal Z over Y because sine is opposite over hypotenuse. Again, so X, Y, and Z are placeholders for numbers, right? Or side lengths, okay? If my focus angle becomes B now, so now I'm focusing on angle B, notice how this changes. The Z is now adjacent, the X is opposite, the Y is still the hypotenuse. So my sine of B would be opposite over hypotenuse, X over Y. So notice when we change the location of the focus angle, our ratio changes. Z and X switch based off which angle we are focusing on. Okay, and again, the letters A and the letters B are placeholders right now for actual numerical angle measures. Cosine. So cosine, looking at our acronym AH, that means that cosine would be adjacent over hypotenuse. Okay? So now we're going to focus back to angle A. So adjacent, the side adjacent to A is X. It's the side touching our angle A. The hypotenuse does not change, still Y. Switch your focus to angle B. So now when I go to angle B, my focus is Z. Excuse me, not focus. My adjacent angle is Z. Hypotenuse, still Y. All right. And again, A and B are still placeholders for angle measures. And finally, we get to tangent. So tangent is TOA, O standing for opposite, A standing for adjacent. So tangent equals opposite over adjacent. So if my focus is angle A, opposite is Z, adjacent is X, so it'd be Z over X. Focus is angle B, they switch. When I focus on B, my opposite is X, my adjacent is Z. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Memorize it. Makes your life a whole lot easier. Okay? So let's see how this would work in an actual example. Okay? So I'm going to put out triangle QRP, and now notice I put actual measurements in there. Notice I'm also not giving you any angles, because today we're only focusing on being able to put the ratios, set them up correctly. So let's make our focus angle Q. Go ahead and put a little red arc in there. So if my focus angle is Q, the sine of Q, the cosine of Q, and the tangent of Q. Go ahead and pause this and see if you can set up the ratios correctly. Okay, so I know sine is opposite over hypotenuse. So, opposite over hypotenuse. So if I'm focusing on Q, the side opposite that is 8. My hypotenuse is always the side across from the right angle, so 17. So again, this Q is a placeholder for an actual degree measure. Okay? Cosine, so C-A-H. It's adjacent over hypotenuse. So focusing on Q, the side touching it, the leg touching it is 15. And once again, my hypotenuse is 17. Tangent, TOA. Opposite over adjacent, the opposite is 8. The adjacent is 15. And that's how we would set up the correct ratios for the trig function that we need. Pause it again, focus the P, same thing. So I want the sine of P, the cosine of P, and the tangent of P. Well, I know sine is opposite over hypotenuse. My opposite is 15. My hypotenuse is 17. Cosine, adjacent over hypotenuse, 8 over 17. Tangent, opposite over adjacent, 15 over 8. Okay? So all of your homework tonight is just setting up these ratios correctly. Now before I end this video, I want to show you how this works. Okay? So let's go ahead and draw one more triangle. WXY. Okay? And let's say that angle X is 67 degrees. And let's say we know that the side length of WY is 10. Okay? And if I want to solve for side length A and side length B. So my focus angle is 67. Now I could find angle W because I know all three angles have to add to 180. I know I have one right angle, so I know that angle W and angle X have to add to 90. So I could find angle W if I wanted to and switch my focus angle. But we usually just stick with the focus angle that's given to us. It's a little less work. Okay? So if my focus angle is 67 and I'm given the side length 10, 10 is the opposite side if my focus angle is 67. So my opposite equals 10. O equals 10. So if I want to solve for A, which ratio uses the opposite and the hypotenuse? That would be sine. So my setup would be the sine of 67 equals opposite over hypotenuse. Okay? And so notice there's three things that get involved here. There's the actual angle measure. There is the two different side lengths. As long as we know two of the three, we can always find the third. Okay? Now what if I wanted to solve for side length B? Well, I'm still going to use the 10 because it's a nice whole number. I'm still going to use my focus angle of 67, but 10 is still an opposite. What is B? B is an adjacent. Which trig function uses opposite and adjacent? So, TOA. TOA. So I would use tangent of 67 equals opposite over my adjacent length. And that's how we're going to eventually use trig to solve for missing side lengths. Now, one more thing I'm going to show you before this video ends is what if we know the side lengths and we're trying to find the angles. Okay, so let's say I have A, B, C, and then I have 3, 4, or 3, 4, and 5. And let's say I want to solve for angle B. Well, I can solve for angle B using any one of my trig functions, and we do what's called the inverse. So if I wanted to use sine, I would do inverse sine of B equals opposite over hypotenuse. Or I could do inverse cosine of b equals adjacent over hypotenuse. Or finally, inverse sine of b equals opposite over adjacent. And in order to do any of these calculations, guys, you have to have the scientific calculator. Okay, and I will show you how to do that and how to press the buttons, but pretty much once you get the setup correct, and we'll talk about this in the next video, it's pretty much all calculator from that point on. Okay, let me know if you have any questions, but again, the homework is only focusing on this stuff, setting up the ratio. Okay, good luck.